Assalamualaikum and good evening to my beloved lecturer Sir Rizal and everyone. Today we are going to present our research assignment QMT342 about one of the waiting line models on famous restaurant in Malaysia, which is KFC. Before we start, I'm going to introduce all of my team members. First of all, my name is Iekhsan bin MUHAZZIB. Next on our team is OWEN DENO, MUAWIYAH bin IZANI, and lastly, ISYRAF IMAN bin KHAIROL FAIZI. For the introduction, to begin with, the restaurant business type is fast food franchise business located in Bandar Perdana Raub, Pahang. This KFC cooperated from 10 am until 8 pm. Next is arrival characteristics. The size of the calling population is finite. When the customers are more than 4 in the waiting line, the rest of them must queue outside the restaurant. The pattern of arrivals at the system is random. Lastly, all of the customers behave patiently while in the waiting line. Next, for the waiting line characteristic and the rest, I will pass to Owen Deno. Thank you.
Waiting line characteristic. The length of a line is limited because the KFC chosen had a small place for the customer to line up. Meanwhile, for the queue discipline, it is first in first out because the customer who comes earlier will be served first compared to the customer who comes next. Service facility characteristic. The configuration of the service system. The number of channels is single channel system as the system only able to serve one customer in a time, excluding the online purchase such as Grab, Foodpanda, and many more. In addition, for the number of phase, it is a single phase system because the customer who came will receive only a counter service to complete their order. And the pattern of the service time is random because not every customer will purchase over the same dish and it requires time for the staff to prepare the dish. Basic queuing system configuration. It is a single channel to multi-phase system as there are only one counter open, which lead the customer to wait for the foods to be prepared after they have done with their payment. Meanwhile, the cashier will continue to serve the other customer after knowing that their staff will get the food ready. Thank you. And right now, I'll pass the next explanation for queuing model to MUAWIYAH.
Okay, thank you, Owen, for your presentation. Now, continue with queuing model. We have the average number of customer or unit in the system, which is waiting in queue and being served in KFC. Our lambda is the average number of arrival per hour, which is 4. And our mu is the average number of customer or items served per hour, which is 6. We are using formula else equals to lambda over mu minus lambda, and we will get 2 customer of the average number of customer in the KFC. Next, we are going through queuing model on the average number of customer in the queue. We are still using the same value of lambda and mu, which is 4 and 6, but different formula. We are using LQ, which is equal to lambda power of 2 over mu times with mu minus lambda. And we will get the average number of customer is 1.33 customer. On the third queuing model, the average time a customer spent in the system. We are using W. W equals to 1 over mu minus lambda, and we will get 0.5 minutes, which is 30 seconds. That's it for me. I will pass to Isyraf Iman for the next presentation. Thank you.
Okay, thank you, Muawiyah. Now, the average time a customer spends waiting in the queue. The formula used here is WQ equals to lambda over mu bracket mu minus lambda close bracket. The value of lambda is 4 and the value of mu is 6. So the formula given is WQ equals to 4 over 6 bracket 6 minus 4 close bracket is equals to 0.33 minute. Okay, next. Model of the utilization factor for the system, that is the probability that the service facility is being used. Okay, the formula used is probability is equals to lambda over mu. The value of lambda is 4 and the value of mu is 6. So probability is 4 over 6 is equals to 0.66. Okay, next, percent idle time, P0. The formula given is P0 equals to 1 minus lambda over mu. The value of lambda is 4 and the value of mu is 6, which is lead to P0 equals to 1 minus 4 over 6 is equals to 33.33%. Okay, for the conclusion, is the number of servers provided adequate? Okay, we can conclude that the answer is yes, because the customer just need to spend their time less for the queue and the system. Okay, for the next conclusion is, are the customers being happy with the waiting time? And the answer is yes, because the average of one customer to wait is 0.33 minutes only, which is very fast. Okay, that's all from us. I have one quote for you. Go to the KFC to buy a chicken pie. Bye bye.